the other reason that it's so nice to have you here is because we've worked, well, Tortoise and you have worked together before, haven't we?
Yeah, this is all your fault.
This is all our fault. I did check in the back and you gave James Harding an acknowledgement. He'll be very pleased with that.
I'll massage his ego.
Do you want to just kind of, we've got some pictures, I think, haven't we, Josh, of the stuff. I don't know why I've got Iran on the telly. Have a look at that, please, boys. Thank you.
There we go.
So, do you want to walk us through kind of
I think that
what
gives
that was?
It gives you a very good insight into the tortoise media psyche. I said I want to talk to you about fecal transplantation, and this is how they presented it. So, this started out with a ThinkIn, actually like this, 2019 maybe? I think it was probably 2019. And the idea was to talk about fecal transplantation. Of course, Tortoise were ahead of the game because now you can't open a newspaper without reading about it. And that's how we started exploring. And at that time they said, James, we'd like you to write a piece about fecal transplantation and the microbiome. And I sat down and I accidentally wrote 20,000 words. They said, we'll write more than one piece, it's okay, but you really need to properly start thinking about writing a book now.
Yeah, and I think it had the imaginative collective title Good Shit, didn't it?
Well, that's what the book was supposed to be called.
Right.
I don't know if any of the Penguin team are here, actually, but they had a bit of a panic 1 month out before publication. They were like, James, we don't think you can go on Radio 4 with a title called Good Shit. So
does that mean there's an alternative cover somewhere?
There is. There is. Yeah.
Amazing. So Elementary, My Dear Crapson. Yeah, so I can hear some sniggering with that. We had a lot of fun, and our art directors had a lot of fun kind of bringing that one to life visually. Before we get into the book, actually, I have a burning question to ask. So because we knew you were coming, and we generally are quite irresponsible and give people beer and wine for this thing, tonight we gave everybody, do you want to, a gut health ginger shot.
Yes.
Has anyone had their gut health ginger shot? Hands up if you drank it. Okay, hands up if you liked it. Okay, fine. Does that stuff work?
So the answer
Have we just wasted a load of money on Marks and Spencer's?
So the answer is it depends on what you mean by work.
Right.
So does it change the diversity and functioning of a microbiome? Yes, it does. But it will only do that if you consistently drink it and you drink enough of it. So your microbes are just like you and I. They've got to feed, they've got to eat. But they will only change their behaviours, and you will only begin to change who is there if you feed them enough to sustain those new populations of microbes that you need. Ginger, interestingly, I can wang on a bit about ginger. So ginger,
have a small wang.
A small wang, a mini wang. So quite a nice study came out from a Chinese group looking at the use of ginger as a food supplement in patients being treated for cancer, particularly cancer with a type of drug called immunotherapy. And actually, particular types of bugs in the gut called bifidobacteria quite like the sugars that live within ginger, and they bloom and they grow when you eat it. And that changes the immunology of cancer, and it makes the cancer drug more efficacious. It makes it work more effectively. So actually, these foods that we kind of think about as gut health foods, and that's kind of a generic general term, do have a real impact. It's just that we don't understand it because we can't measure it.
Okay. So on balance, drink the shot.
Drink that. And more importantly, actually, just don't follow it with a beer. So beer's not so good for the microbiome. Red wine, much better. Polyphenols, lots of good stuff in it. But it's of course, like, that will only make your microbiome so well if you keep eating all the other things that are less good for it and drinking the other things that are less good for it. It's going to undo your good ginger work.
Excellent. Okay. So, well, that's the official advice on the ginger. One of the things that's quite clear from the book, and I guess it's one of those things that everyone sort of knows, but it's still quite shocking when you see it in print in front of you, is just sort of how damaging 21st century life is. Just generally, like, it seems like we've not just the sort of bad things we invent that are fun that we still do, you know, like drinking and smoking and everything else. I'm not saying smoking's fun, but
it is. It's really bad.
I mean, the bit that jumped out at me was, so I'll just read a couple of sentences. 21st century living is causing our airways to close, our skin to flake, our joints to swell, our guts to bleed, our arteries to clot, and our brains to seize up. The global pandemic of non-infectious diseases is arguably a greater threat to humanity than that caused by any communicable disease.
Yeah.
I mean, it's pretty bleak.
Well, so look, it depends which way you look at it. we're living longer than any other moment in history. And that's because we've been unbelievably good at killing pathogens and sustaining large populations on cheap, bountiful supplies of food. And, you know, the revolution in hygiene, antisepsis and asepsis saved millions and millions of lives. So in some respects, actually, it's been a tremendous success. We are living longer. The problem, I'm arguing, is that we are not living happier. Right. And the reason we're not living happier is because collectively modern living is causing a kind of internal climate crisis. We have inadvertently started to destroy the microbes that we need to sustain our health and happiness in our pursuit of killing pathogens that cause us historically lots of harm.
And I mean, actually, I don't know if that's too early to sort of go into the bits that we mentioned just before you came out, actually, but you kind of define, don't you, these sort of 5 or 6 areas where basically our microbiomes have taken a bit of a kicking.
Yeah, so it's kind of, it's hard to talk about because every time I talk about this in the public sector, people go, tell us some good news, right? And I think what people really want to know is that if they eat a bit of kimchi, this is all going to get better, right? And it isn't. And actually, it is a bit bleak. Right. And what I've tried to talk about is how we have destroyed the microbiome, or we are destroying the microbiome in a comparatively or evolutionary short timescale. So basically since the Second World War. And there are a couple of key drivers, right, of that. One is very obviously antibiosis, like antibiotics are bad, right? So we are living really in an antibiocene. And that really bloomed from the 1940s. The second is diet. We have a hyper-globalized diet, which is typically westernized, and that's really not very good for our biodiversity. The third is, I would describe it as urbanization. So 65% of the world will live in urban environments by 2050, and that is fundamentally changing our microbiology. Number 4 would be pharma. We take an astronomical number of medicines each year on. We take about 4.5 trillion doses of medicine globally each year, which means that somewhere on the world today, half the planet's population is taking a medicinal drug. That changes the microbiome. The 5th is conflict. Global conflict that's really been going obviously on for centuries. Really started in the 1600s, was escalated in the 19th and 20th century. It moves populations around the world. It drives antimicrobial resistance. It causes climate change, which of course is the 6th, the most important. We are experiencing a climate change, and because the microbiome intimately connects us with the planetary microbiome, therefore we have to be affected by it.
I mean, it's interesting. So all of those things kind of either start to or accelerate from the middle of the 20th century, right? And like I mentioned just before we came on stage, I think a large part of this, and actually a large part of the book, keeps referring to kind of the relationship and how we view our microbiome, if we view it at all. Actually, I'm speaking as someone that probably didn't even know anything about it until adverts for gut-friendly yogurt with Martine McCutcheon started appearing on the telly.
She's a compelling saleswoman.
She knows her stuff, and it got me thinking, because I not to bore everybody, but I come from quite a large Catholic family, and I'm the youngest of 5. And my mother had me when she was quite old, and her mother had her when she was quite old, also a large family, which meant that the housekeeping at home was quite 1950s in its execution. So, and also it was above a pub, so it's a commercial space. So basically, I grew up surrounded by a lot of bleach. A lot of bleach and sort of scrubbing and industrial cleaning and things like that. So in one sense, we were not regarded as clean unless we smelt of bleach and our skin and our hands had been sort of scrubbed red. Raw, exactly. That meant cleanliness and a lot of pain. But that's, and I have an unusual relationship with cleanliness. But weirdly, also food waste was a thing. So food could be dropped on the floor and left there for an hour, and I would still be expected to eat it.
Quite right.
Yeah. So, and I always make a joke at work about how I'm never sick because I rolled around in the dirt a lot as a child. And I think it's because actually I ate a lot of dirty sandwiches off the floor.
But they're high fibre sandwiches.
The high fibre sandwiches. And I shouldn't say this because I can see Michelle in the corner of the room, but generally 9 times out of 10 I phone in sick, it's probably a lie because I'm quite a healthy person. And I was curious, like the sort of, I've overshared all of that information as a way of kind of setting up a question about like our cultural relationship with bacteria and how that's changed.
So I'll try and answer that. There's a few key things in what you have said. So the first thing is that there is no such thing as good and bad bacteria. This is a marketing myth and it's nonsense. You can't anthropomorphize bugs. They are not good and they are not bad. There are pathogens that cause us harm. So SARS-CoV-2 was a pathogen. Ebola is a pathogen. There are symbionts which we have a mutualistic relationship with, which we have co-evolved with, right? And some of those symbionts we have very obvious examples where they have an obvious benefit to us. Some of them we're not sure about, and some of them kind of do us harm in a slightly belligerent way, but we tolerate them. Okay, and so we shouldn't anthropomorphize them. They are just responding to the stress that we put them under. That's kind of the main lesson. The second thing is what you're sort of describing. In fact, quick question: you're from a Catholic family. How many brothers and sisters do you have?
I have 2 brothers, 2 sisters.
Okay, so that's the main thing, right?
Yeah.
So there was a theory that came out in the 1980s called the hygiene hypothesis by a guy called David Strachan, who was at St George's, and he was trying to explain why there was a rise in asthma and allergic conditions in the population at the time. And he thought, well, maybe it's just because they're too hygienic. And that was it became quite influential. And that theory has kind of evolved a bit over time, and it's evolved now into something called the disappearing microbiome hypothesis, which was first described by a guy called Martin Blaser in New York in about 2009. And what it says is actually it's the changing environment which is causing a mass extinction event in our microbes. And because these microbes are so important in educating our immune system, we are therefore experiencing this rise in the pandemic of immune-mediated diseases. So this idea that you're bleaching your hands probably does affect your microbiome in a really important way, but actually you're in a household with a bunch of siblings, and I bet you when there's like a lot of you, there's 4 of you, right? Mum is actually saying, get out the door because you're making lots of... So you're interacting with your siblings and you're sharing microbes. So what we also know is that families who have a very large family network have a more biodiverse ecosystem, and they have more resilience in their microbiome than small families with single children. So actually, there's multiple dynamics occurring within your household alone that are shaping your microbiome. And the final piece to say is that you have to conceive of the microbiome through a couple of different paradigms, and one of them is time. The microbiome is not constant. It shifts within us as we age. It shifts within us from the minute we are born to the minute that we die. And we can talk about that in a bit more detail if you like. But those changes that you experienced in your childhood would have had a very important influence on your risk of chronic disease as you age. And the earlier those things happen in your childhood, the more important they are. And again, that goes back to epidemiological theory that's been known for quite some time. The microbiome just reshapes it and it explains it and it gives it a different context.
There was an astonishing bit which I saw when you're talking about the maternal biome and the birth and when you're young children, very young children, and when young children are given antibiotics at an early age, and that has a massive impact, doesn't it?
It really frightens me.
Right.
So I've tried to talk about this from a really personal perspective in this story by talking about my own experience of my kids and them getting sick and me giving them antibiotics. Because we've all done it, because antibiotics do save lives. They're really important drugs. But so just to take a step back a little bit, I've described the microbiome as being dynamic and evolving over time. So my current kind of passion project is actually the maternal microbiome. I believe that the maternal microbiome, it should be a fundamental human right, and I can explain why. But the maternal microbiome kind of signals to the developing and gestating infant, and it doesn't do that by colonizing the infant directly. It does that by producing lots of this huge cascade of small molecules that we just don't understand, right? And the way that I conceptualize it is you have to think about it like it's an orchestra and it's playing a song. So we have this concept of orchestral signaling, and that signal of tunes will cross the placenta and it will shape the developing infant in a really, really important way. So if you perturb or disrupt the maternal microbiome at key moments during gestation, we think that has a very important part in explaining why their offspring have increased risk of things like diabetes, obesity, and cancer when they hit their 30s and 40s and 50s. And there are also generational effects that happen across the microbiome within that dynamic. And we know from really good studies that have been done longitudinally in Scandinavia and actually across the world that when you perturb the microbiome in infancy, at that critical moment when it's being shaped, between 3 to 5 years old, what you do is you discombobulate the immune system, which no longer can deal with the changing, shifting environment of the world that we live in. And therefore you see asthma, allergy. And what you see is you see a sort of predictable change in how these allergic systems kind of develop as you grow. So when you hit the immune system is really, really important.
Right. I mean, there's, one of the things that sort of leapt out at me was, I hope I've got this right, but you mentioned something like allergies. By 2025, half of the population...
Half of us will have an allergy. Like half of this room, I'm sure, has allergies, right? They're just endemic. But that wasn't always the case.
And is that all allergy? Is that like, oh, I sneeze when the cat comes in, or is that like?
Yeah, it's all allergies. So rhinitis, these sorts of things, right? So, but what I'm trying to explain is that you can't look at one disease in isolation, which is what clinicians love to do. Right. So like, I'm a cancer doctor, so that's all I look at, right? But so you've got to look across the portfolio of awful diseases, right? And asthma's doing this, inflammatory bowel disease is doing this, rheumatoid arthritis is doing this, mental health problems are going up, cancer's going up, obesity's going up, cardiovascular disease is going up. These things all have a common origin, I'm arguing, and that is the dysfunction of the microbiome at critical moments in our development.
Sorry, I forgot to mention at the beginning, you're a cancer doctor. Did you really write this book in the operating theatre number 3?
Yeah.
Yeah?
So I did. So this sort of story starts with me doing an appendectomy on the morning of 9/11. And that's completely true. And so you see the prison. I did my PhD in the same hospital where I work. I've never really left. I'm a bit immature, really. And so yeah, you see a changing dynamic healthcare system, and I've watched that change in 20 or 30 years, and it kind of broke me in COVID, and that shaped the writing of this book. In fact, I started writing this just before COVID happened, and then I just had to rewrite it during COVID because I became so angry. I'm happy.
It's excellent therapy. Yeah, no, the output is amazing. And actually, let's just stick with like the maternal microbiome and young children for the minute, because you talk a lot about, well, you don't talk, but you go into some detail about the difference between sort of C-sections and the impact that they have on microbiomes as well. Yeah. I mean, what I'm picking up from this book is that everything impacts on microbiome. But
so the microbiome is everything, everywhere, all of the time. And one of my mates is like, I share an office with her. She's a colorectal surgeon. She's like, God, James, it's all about the microbiome, isn't it? I'm like, I'm sorry, well, it is. And of course, when you've got a hammer, everything looks like a nail, and I'm a microbiome scientist, so yeah, but it kind of is. And what I'm arguing, actually, is something quite fundamental, which is that we know that most diseases, not all, but most, are caused by a genetic susceptibility. So you're born with a set of genes that say, actually, under the right environmental conditions, you're more or less likely to get a disease like bowel cancer, right? So we know that 25% of my patients probably have some form of familial disposition, and they spend a life eating cheeseburgers, and lo and behold, they get bowel cancer. What I'm arguing is actually you have to conceive of it in terms of gene, environment, microbiome interactions. The microbiome is so fundamental because it literally and figuratively and philosophically sits between your genome and the environment that you experience. And it processes absolutely everything you come into contact with. It might be microplastics, it might be the air you breathe walking home tonight in London, it might be the meal that you digest when you get home.
Okay, high stakes it feels like.
Yeah.
Like
every breath you take, that's 100 million viruses.
Yeah, actually, you mentioned there was a similar stat in the book about kissing as well.
Oh, I love kissing.
Which...
you should kiss, it's really good for you.
Yeah, but oh, so it is good for me.
Yeah,
because I thought if I kissed for longer than...
now, because that would be...
Well, I mean, but it has to be for 10 seconds, right, for it to work, yeah?
Exactly.
Is it bad if it's less than 10 seconds?
Well, I think it's less passionate.
Right.
So, yeah, I think it's less meaningful.
I'm quite impatient. I get bored, tired, and hungry quite quick. So, yeah.
So the point I'm making is that there's an evolutionary basis for kissing and for sex, and part of the theories for that come from our ability to detect parasites and from our ability to share microbes that might be kind of important. So when you look back at microbiome studies done in Neanderthal, because you can look at their dental microbiomes and you can sequence them, actually we think there are microbes shared between Neanderthal man and Homo sapiens, right? And these microbes actually, so it's like, and these microbes actually have quite important functions because they helped you metabolize things like starch, which we started to farm, right? But also they had antibiotic properties, right? So kissing shares microbes. You share about 50 to 80 million bugs, a snog, basically. It's super hot, right? Yeah.
I mean, I read there is a very entertaining but quite difficult to read chapter. So I read sort of most of it like that, when there were phrases like, talking about the bacterial colonies in my penis and healthy vaginal microbiomes. Yeah, that was. But there's a story at the beginning of it which I loved, and I'm going to paraphrase it now. And you can tell me if I get it wrong. Okay. So, a younger you is on holiday, and you meet a girl, and you pluck up the courage eventually to talk to her, and one thing leads to another on this holiday. It's a very chaste relationship, and one day she suggests holding hands. She did. Yeah, and you frankly bottle it, and she's off. Yeah. Right, it's a whirlwind romance, but a real roller coaster of an emotional journey, and you basically pose the question: was it your microbiome getting involved and influencing you that you didn't want to hold her hand?
Like, I totally did want to hold her hand, and actually, we got married in May.
Oh.
Yeah. So she came back, and we stuck it out like we were 14.
So did you overrule your microbiome?
I think intense. So the point I'm trying to make is that microbes influence our behaviours in ways that we probably don't properly understand, and one of those is through the metabolism and the bioavailability of our androgens, our sex hormones. Right, so it's a really big player in estrogen and progesterone and testosterone, and it not only allows us to sense and use these hormones, but it influences how they function. And we're only just beginning to understand this, and that has very, very important consequences, not just for how we choose our partners or for the behaviours that we have in terms of the pursuit of our sex lives and our sexual health, but also for how men and women or people of different genders experience the health consequences of their gender or their sex as they age. And that's the point I'm trying to make. And again, it kind of comes back to like antibiotics. If you have antibiotics before puberty, that has a very big impact on the consequences of your gender-associated or sex-associated health as you age. And we don't understand it. And the vaginal microbiome we should totally talk about. And we should not be squeamish about it, because it's. Did you know the world's first vaginal microbiota transplant happened this year?
I didn't.
Well, there you go. Now you do.
Was that here, or was that?
No, it wasn't here.
Right.
It wasn't in the UK. But actually, the vaginal microbiome is incredibly important, not just for determining the health of women, of course, because it is also dynamic and it changes as you guys age. Quite obviously not a woman, but just felt like I should make that clear. And but it's also so important for fertility, right? And actually, we got a big fertility problem, right? The world's fertility rate is dropping and declining alarmingly, actually, as one of my quite good colleagues who's a vaginal microbiome scientist in Florida said, like, if this was the male microbiome, we would have fixed this problem like half a century ago, right? So actually, I think it is something that we should be talking about a bit more and that we just don't.
And is that sort of based on the same principle like the fecal transplant thing, where you take stuff from a healthy person and...
Yeah, it's about reconstituting a community of organisms and improving the bioresilience of that niche to deal with environmental stress, and probably also to reprogram the immune system that determines the health of that piece of anatomy. And it's really, really important. Men, by the way, it's just as important. So we know that obesity drives rates of infertility, and in men that's important because bugs control how vitamin A gets absorbed, and that influences how you make sperm, right? So men are just as vulnerable to these microbial shifts when it comes to sex, and gender-associated health, and we should be talking about it more, I think.
I mean, actually, the chapter is brilliantly titled "Sex and Bugs and Oestradiol." Yeah. So yeah, I enjoyed that. I giggled over that. So so, sorry if I'm labouring the point. So, is there a relationship between attraction and microbes? Or my microbiome?
No. So they influence how you smell, how you look, how healthy your skin is, and a lot of the kind of visual prompts that we have when we're looking for partners. We know that there are evolutionary bases in other animals. So, for example, rats will choose their mate based on the odor of urine because they can smell parasites.
We don't. John.
Exactly right. We don't think about that in a human context. So I'm asking the question: maybe should we? Maybe we should re-examine this. Does it really choose your mate? No, it doesn't really choose your mate. Of course, it doesn't. But what it does do is it influences these behaviours and your kind of subtle selective choices that you make. You are autonomous. You choose who to sleep with and who to have a relationship with. Of course, you do.
Okay, so basically, I'm not alone in my relationship the way I thought I was. Okay. Fine. I should say, if anyone's got any questions or anything they want to share, please try and catch my eye, put your hand up. We've got one at the back. Yeah. Ange, can you pass the microphone back? Can you just say your name, sir?
Yes, hi, my name is Jonas, and I think you touched on kind of epigenetic kind of influences, and I'd just be interested, at the moment, like there is a lot of kind of nutrigenomic testing and stuff. Is there anything, like, are we at a stage where publicly available nutrigenomic testing is actually telling you anything meaningful, or is that more like just money making?
Can you just translate his question into something I can understand?
So what he's asking is, sorry,
Thank you,
I'm going to translate, and if I get what you're saying is wrong, please correct me. So epigenetics describes non-heritable changes in our genome. So damage to your genome that has an important effect on your health, but actually you don't hand on to your children. You don't. It's not heritable or transferable, I should say. And what we know is that these are really important in defining your disease risk. Okay, so we used to think it's just what genes are there, and then it turned out to be, okay, actually what are those genes doing? And now it's, how are those genes being damaged kind of day to day, and what does that really mean for the expression of those genes? Nutrigenomics means, can you predict which foods are going to work well in which people based on an analysis of their genes?
So will the kimchi work better?
Will the kimchi work better in me, or will it work better in you? And there are certain scientists out there. Well, in fact, so the short answer to your question is 100% we are moving towards precision dietetics or precision nutrition based on an individual's measure of their biology. And what we are understanding is the microbiome is incredibly important in determining how you break down your meal and how you experience the health consequences of that meal over time. And I would strongly argue that you cannot have precision dietetics without the microbiome. It's impossible. So if you're having a purely genetic prediction of diet, it's absolute nonsense, because the majority of the enzymes that break down carbohydrate are actually microbial. They are not human, right? There's a bigger question, like, are the ones that you can buy online that are heavily marketed online and social media, we won't name names, like, do they work? Should you buy them? I don't use it. And I don't use it because I don't think we're there yet. I think we don't have standardization in sampling, standardization in the analytical things that we do to measure the genes and who's there, and most importantly, we have huge variations in the computations that we make on that data set to make predictions, and we just don't have enough evidence that we're really working. My bigger problem with it is that these are for rich people. These are for the middle classes. These are not solving anybody's problems in a cost of living crisis, and we all know it's people who are poor, who can't afford to eat well, who are going to be obese and get cardiovascular disease, and are never going to sequence their genome and don't care. And actually, you can change people's microbiome through better healthcare, through better nutritional food policy, and better regulation, and by making foods that are good for us, that we know work through the microbiome, affordable. And we can do that today, and we don't need to sequence the microbiome to do it. And so what I'm interested in is using the microbiome to reframe that whole conversation about what a healthy diet is, And if I could just, like, I can't tell you, like, the conversations I have in my clinic, trying to explain to people what fibre is. Like, people just don't even know, like, fundamentals and how important it is. So where I think its value will be in precision treatment of specific clinical conditions. So I want my poor patients with cancer to know what to eat so that their drugs work better and more effectively, and they don't get side effects, and they live longer. We don't have that at the moment. And I think that's the bigger play. So I think that's going to come in through trials. Sorry, Jonas, a slightly long-winded answer to your question. I got a bit carried away. Yeah.
What is the obstacle to that understanding?
There's a
An
few.
application of that.
Yeah, there's a few. So the answer is that we probably have the know-how to do it, but there is still quite a big missing piece in the puzzle of, like, truly what the microbiome, who is really there and what they're really doing and when they're doing it. Right. That's actually still quite a big open-ended question. The second is money. Yeah. Like, what you have to do is you have to persuade funders who fund clinical researchers to do this work and to meaningfully invest in that, and they've got to be incentivized to do it. But also, like, you're a very enlightened crowd, right? You guys are super on it. Like, you're obviously biased, but, like, if you go to the average, which I do quite a lot, if you go and speak to the average, clinical conference of doctors, most of them have no idea what the microbiome is or who is there. They know it's something fashionable and they probably should know about it, but if you really get into the detail, they can't really tell you what's going on. And that's not their fault. It's just because the science is just slowly catching up. And so we are just right at the beginning of this journey, and there's quite a long way to go, I think.
And it is the understanding that is there, is the science sort of generally well regarded and accepted, or are you, okay, it is. So you're not, like, lumped in with the homeopathy people or something?
No. And well, look, I feel for the homeopathy people, and I'll come back to that. Like, this is a super young science. We've only been going for 20 years. Right. And all of the science that comes out is totally mind-blowing, and I absolutely love it. But it's all in animals, and it's all in, like, early stage preclinical work. And that's no good if you're a jobbing GP in, tooting. It's too far removed from reality. So this is preclinical basic science research, and it's got to translate into the clinic. And that's going to take a little bit more time. We'll 100% get there, but it's going to take a bit more time. Homeopathy is super interesting because, like, some of my patients come in and they're like, James, I've done this and it's made me better. And I'm like, well, okay. Like, who am I to say it hasn't? And I think the microbiome plays a part in this because it explains our massive individual variation, how we respond to all treatments, but it also influences our health through gut-brain interactions, which we are just only beginning to understand. If you believe that something is going to work and you feel less anxious about it and you feel less stressed about it, that has a real meaningful impact on your gut's immune system, where your bugs live. Yeah. And it changes what your bugs are doing, and it has a kind of mechanism. And because we don't understand the mechanism, we poo-poo these things. Right. But then, I don't know, I used to be deeply cynical about it, but the more I learn, the more open-minded I am about it. Like, if my patients want to have acupuncture, go and have acupuncture, 100%. I'll totally support you to have it. And I, there's a lot of quackery out there, don't get me wrong, but maybe. But
I mean, you talk a lot, actually, about the link between mood and microbiome. And actually, yes, your mood can affect your microbiome, but also your microbiome can affect your mood, or at least there are signs that you can get in a better mood, and there's dopamine and things like that. Yeah. Do you want to just kind of walk us through that a little bit?
Yeah. So there's a lot of interest in something called gut-brain interactions. So this idea that the microbiome plays a very important part, not just in your functioning now because you're all adult humans and how your brain works, but actually in the development of your brain. So how your brain forms and how it forms network collections and how it shapes in early life. And then also how it degenerates as you get into late life. So your risk of autism, Parkinson's, and dementia. And then in between, how you experience and feel the world as you kind of live your life. And we know that there are three broad mechanisms through which that works. The first is through your immune system, because your brain has its own immune system and the microbiome can regulate it. The second is through the vagus nerve, which is kind of a big part of your autonomic nervous system, that actually the majority of the vagus nerve takes senses from the gut back to the brain. It's actually up up traffic. And the third is through metabolism and the generation of small molecules. And you talked about neurotransmitters. The gut makes neurotransmitters. Actually, those don't go to the brain directly, but it creates precursors for these, and it can influence how these work. And we're starting to unpick those mechanisms. And there are these kind of amazing fecal transplantation experiments done in animals where you can really change behavior. So if you take autistic twins, where one twin is autistic and one twin is not autistic, you can take the feces from that twin, you can put it into an animal, and you can generate autistic behaviors in the animal. And then if you take the feces from the twin who's not autistic and you put it into him, those behaviors will recede and they will go away. And we have a compelling, and it's a super controversial thing to talk about, and I appreciate it's kind of like not an easy thing, and that autism, like so many other conditions of neurodevelopment or neurodiversity, is caused by multiple factors, right? And I'm not suggesting the microbiome is everything, but it's certainly a massive part of it. We've got really good and interesting, epidemiological evidence and emerging evidence of longitudinal microbiome studies in infants. Kids who have autism have a different gut microbiome, 100%. But we just don't know whether it's a cause or an effect. Like, is this driving autism or is this a response to it?
Okay. Oh, wow.
Yes, ma'am.
Loads of questions. Can we get the microphone to the...
Yeah.
Oh, you've got the microphone. Oh, no, sorry, you go first, babe. Yeah.
I'm Mila, by the way. I just thought I'd ask, so when you were talking about gut-brain, the relationship, do you think things like anxiety and depression, is there a relationship between that and your microbiome? And if you worked on your microbiome, would that have an impact on things like stress, anxiety?
This requires a careful answer, and I'll be as careful as I can be. So the answer is that we know from quite big European studies of many thousands of patients, that participants who have depression or anxiety do have differences in the microbiome, and we can measure them, and they are consistent between cohorts. And we also know, and we're starting to understand, how the microbiome shapes brain development and causes symptoms like anxiety. And I'll give you an example. So, for example, particular strains of bugs influence the production of vitamin B, a particular vitamin B that influences how nerve fibers lay down fat that helps them communicate messages and share brain development and influence brain development, right? So we're starting to understand mechanism. We can see things in populations, but we have to be quite careful because, of course, if you experience trauma in your life, or you spend too much time on TikTok, or you're isolated through COVID, of course there are environmental drivers which cause depression and cause anxiety. So the cause and effect discussion is quite hard. And we should obviously, acknowledge that there are clearly environmental drivers for mental health that have got nothing to do with the microbiome. But what I am saying is the microbiome influences your susceptibility to these things, and also that you can then target the microbiome. Right? And so therefore it becomes a therapeutic option where we don't have any. And there's this notion of psychobiotics, that you can take probiotics engineered to target particular components of that gut-brain interactions at particular moments in your development, and that might be a way to target it. And then you're seeing things like fecal transplantation being used quite successfully to treat conditions like addiction. It works in alcohol addiction, it works in drug addiction. And so, yeah, I think it's a really important part of the bigger engine for mental health. I just think we're super early in our discovery of what it really means.
We can pass the mic along here. Thank you.
Hi, my name's Charlie. Can you hear me? Yeah, good. I was very interested when you talked about the vagus nerve. Could you talk a little bit more about that? Particularly, have you done studies in people that don't have one, or it's been severed?
Yeah. Well, I haven't. So back in the day, I'm a surgeon. Surgeons are terrible. We just terrible things to people. Oh, I'm so sorry. So we used to cut the vagus nerve for people that had ulcers. So if you had a gastric ulcer back in the day, we used to do an operation called a vagotomy. And if you cut that nerve, it's such a stupid thing to do because it's caused by bacteria, right? But we just didn't know that, right? So we just cut their vagus nerve in the hope that we would stop secreting acid in there. So all we did was cause gastric paralysis. But you can look at these populations, and actually, if you've had a vagotomy, you're much less likely to get Parkinson's. And if you look at animal models where they have cut the vagus nerve because it's slightly, but not much more ethically acceptable to do it, actually, yeah, you can change the risk of these animals just don't get they just don't get brain degeneration. They just don't get these symptoms at all. And so, yeah, there is quite good experimental evidence and epidemiological evidence for it. But what we just don't have is the real detail in precisely how microbes are signaling up through the vagus nerve and how they kind of manage to do this, and how they're really influencing, if they really are at all, the deposition of proteins in the brain that cause things like Alzheimer's and Parkinson's, right? They're called amyloid plaques. So bugs actually make amyloid. E. coli makes amyloid. Lots of them make amyloid. We just don't quite know if they're really shipping it up there or whether there's an immune response to it and precisely what role they're playing in it. It's all kind of being worked out. And you talked about like the speed of microbiome science discovery. Like every week you're reading another paper and you're like, oh my God, this makes sense. Oh my God, oh my God. So it's frighteningly fast.
Can we get the microphone back to John? And then this microphone here, can we pass it to the lady there in the jumper? So John, if you want to go first, and then I'll come to you, madam, at the front.
So yes, John, I really love the language that you use to frame it and the concepts, and it makes it feel really alive and emotive. It made me wonder is it just doing its thing, or does it have, like, is there a collective consciousness within the microbiome? Yeah. And if so, should we be talking to it like we might talk to plants? Yeah.
So I've tried to write about like symbiotic sentience. Like, is there a collective awareness that, like, is it like The Last of Us, right? Is there a fungus inside of us, like driving us around, subconsciously controlling our thought? I don't think it is. What I think it is doing is shaping our behaviors as it makes subtle adjustments to our physiology and biology to get what it needs to survive, right? Listen, I wouldn't be surprised if there comes out a piece of work that it says that they might. But bugs do kind of super interesting things. So they do this thing called quorum sensing. I don't know if you've heard of this. So bacteria and microbes create their own hormones, and they collectively sort of sense those hormones and behave a bit like a flock of larks. Like, when you see them in the winter, they behave just like that. And they will pulse and they will share those messages and behave as a kind of connected network. And you can see it. You can program them to fluoresce, and you can watch it. And then actually, if you're really clever, which some scientists at MIT were, they can engineer that to release enzymes that kill cancer cells. So you can take advantage of these things kind of for human benefit. So I don't think that they are controlling our mind in the way that we think, but I wouldn't be surprised if someone comes up with some work that says that they do.
Man, do you go next?
Right. I was raised on penicillin. We used to call it the ice cream medicine. Yeah. I have celiac disease. My brother has late onset type 1 diabetes. Obviously, it has occurred to me there's a connection. Yeah. So I don't know whether you're going to come to this later, but is there anything at this stage in my life? I mean, I don't like kimchi, but I do eat other good stuff. But is it just like the damage was done when we were small children and just forget it and eat burgers, or what?
Burgers are so tasty. They're so wrong.
They're really good.
Yeah. So I believe that there is enough evidence to suggest that the widespread and misuse of antibiotics in early life causes harm, meaningful harm, and that it can in part explain why you have a risk of type 1 diabetes risk. And actually there have been some quite nice studies done, again in Russia, looking at populations that are divided by geographical barriers, where one has a high degree of risk of type 1 diabetes and the other does not. And you can actually go back to antibiotic use in early life, and you can track the evolution of the microbiome and how the microbiome influences the immune system, which attacks the pancreas that causes the diabetes. Celiac disease, again, very interesting one. For those of you that don't know what celiac disease is, it's if you like, it's an intolerance of gliadin, which is a protein that you find on wheat and barley, and you develop an immune response to it, and your gut is very unhappy if you have that. We know that microbes have co-evolved with wheat, and they were kind of a really important part of metabolizing yeast and breaking it down in our gut. And now we've got these kind of weird super strains of wheat, which actually our microbiome just can't cope with, and that's part of the problem. We know that the microbiome is part of the immune response to celiac disease, but we just don't have any of the detail to it. I think you're right. I think what happens is that when the immune system is not programmed correctly in early life, trying to correct that system is incredibly hard because of its complexity and because of its connectedness, which is why people are giving fecal transplants. Because actually, to make small changes like eating a bit of kimchi, right, the poor kimchi manufacturers out there. Yeah, well, I do too. But it's just not enough because it doesn't have enough big enough hit to reprogram the entire system. So some argue that FMT is a bit like turning a computer on and off again, and actually you're just completely resetting it. But the only way to do that safely is to probably now do that through a trial, because again, we don't know what the longer term implications are of fecal transplantation.
You mentioned the geographical. The geographical study, and there's a bit in the book where you talk about when the Berlin Wall comes down, and you have the sort of a Western kind of microbiome influenced by Western diets meeting an East German different diet with malnutrition and things like that sort of into it. Do you want to just sort of, because that was quite interesting.
So you can start to understand gene, environment, microbiome interactions by looking at divided societies. And luckily, at the moment, for epidemiologists and microbiome scientists, walls are going up everywhere, they're not coming down. But East Germany was quite interesting because a wall went up and divided a city overnight. And that city was populated by a homogenous cohort of people who were genetically pretty identical and had a pretty similar historical background and lived in a very similar environment. And then overnight it changed. And what happened if you lived in East Germany was that your life expectancy dropped and you died younger and you got diseases of deprivation. And if you lived in West Germany, you got diseases of a perturbed immune system. So you got asthma and you got eczema and you got allergies and you became obese and you had all these problems. And then, of course, yeah, well, I don't. It's like a smorgasbord. And then the wall went down after 20-something years as quickly as it went up. And then what you saw was that population change. Life expectancy climbed within about 20 years in the East German population up to that of the West. And then they started to get allergies and all the problems that a Western population had. And the question is, well, why? Like, what caused that? And there is nuance in it because it's not quite as straightforward as that. But what I'm arguing is, in this book, is that it's taken a generation because of the importance of the maternal microbiome, because of the importance of the damage to the microbiome in early life for those changes in epidemiology to manifest themselves. And then those environmental changes that come with a westernized, living, wearing your denim and going to Disney and, eating crap to take effect, right? And actually you can replicate that in other kind of cohorts of populations around the world.
Nina, I saw you had your, we've got brilliant. Nina and then Lucy here at the front.
Thank you. My name is Nina, and I would like to ask you, first of all, there were a few studies trying to understand how Bulgarian long livers, what do they eat since Mechnikov's times. You obviously know that Russian School of Microbiology. Now I see the same thing about Japanese long livers, and it seems like it's not working. I mean, all these probiotics, you just take the course of 2 weeks after antibiotics and it goes nowhere, and you are eating your burgers or I don't know. So and what do you say about this transplantation? Seems like a magic pill. Magic surgery, I would say, yeah? So how far are we from the point when, for example, I know that I've got some disease which I would like to get rid of. I come to the clinic and I say, would you please transplant, do that to me with the microbiome of a person whose microbiome can fix mine. And also the problem of an ideal donor is there, because if I want to get rid of Alzheimer, where is the guarantee that my donor doesn't have diabetes or ADHD or... So how doable is all that?
I'm going to try and answer that in a concise way. It's kind of hard because there's so much in your brilliant question. So the first thing is, if you don't know who Elie Mechnikov was, he's like the godfather of immunology. He is the Don, right? And he actually came to the conclusion that the colon is a cesspool, a vestigial cesspool of disease, and that we should not eat raw food because it kills us, and that we should have colectomies because then we'll live longer. And he became obsessed by microbes and had this, went to Bulgarian populations and had Lactobacillus bulgaricus, which he named as this kind of milk fermented probiotic that made them live longer.
So basically Yakult.
Yakult, yeah, basically, yeah.
Other fermented milks.
Right. And of course, that's not quite how it works. And there's been, I forget his name, the blue zone guy, goes around the world looking at different populations. And of course, it's all a slightly false epidemiological construct. What I would say is the microbiome plays a very, very important part in our aging process. And the reason is because our aging is defined by our immune system. So healthy aging is defined by how much inflammation you experience, so what we call inflammaging. So when you have too much of it, right? Because in my clinical practice, I'll see someone in their 60s and they'll look like they're 80, and you think, oh my God, I've got to operate on you. And that's biological aging. It's not chronological aging. And that's because they smoke and they don't exercise and they experience inflammation. And then as you age, your immune system declines. It's called immunosenescence. It stops responding. It goes from being not too active to being not active enough, and it can't cope. And we know that aging is a balance of these processes. And the microbiome sits right in the middle of it. So studies done in centenarians, so Japanese people that live over the age of 100, right, that have sequenced their microbiome, find actually that these people do have different microbiomes. And those microbiomes have different functions. So, for example, Japanese centenarians metabolize bile differently. Bile is the green stuff that you vomit when you're really sick, but it's a super important biological fluid that has lots and lots of functions. And so we're starting to understand some of the complexity that explains that phenomenon that Elie Metchnikoff talked about in the 1900s. Can you fix it all with a single probiotic? Of course you can't, right? One probiotic isn't going to make you live longer. Having one FMT is not going to make you live longer unless you nurture that FMT. You've got to look after it. It means you can't have an FMT and smoke 40 fags a day. It's not going to work, right? But what you can do is use the microbiome as reframing the discussion about what healthy aging really is and how you look after populations who are vulnerable when they are old. So old people, when they go into a care home, all their microbiomes homogenize because they're given the same crap food, they don't exercise, they're all on the same drugs, and they become frail. And you can map frailty onto the microbiome very accurately. So maybe you could reframe your question and say, well, actually, in old people who are in care homes, how do we improve the diversity of their microbiome so that they don't experience the comorbidity of aging and the misery of aging, right? And therefore, it becomes a therapeutic target in its own right.
Can we get the microphone down to Lucy at the front? And just while that's on its way, and I'll come to you at the back. So very, very quickly, there was a phrase that struck me in the book where you talk about the war on terror and the microbiological chaos it caused. And you mentioned conflicts as one of your 6 shaping forces. And I think out of all of the 6, that's the one that probably if I'd been asked to draw up a list, I wouldn't have come up with it. I don't think anybody would. Yeah. So can you just give us a kind of précis on the conflict element?
I had a whole chapter on Christopher Columbus and what a pain in the arse he was and how awful he was, because that was the first time that biological warfare really became a big deal, right? So in the 1600s, when they went into Central America, I mean, they just wiped out 50 million people by giving them Western, parasites and infections to deal with. And it is also the first time that conflict created global trading networks. Global trading networks were all built around conflict, right? In the 1600s, and we had lots of European states behaving really, really badly, trafficking people, invading people, and doing generally terrible things. But if you look at more modern conflicts, what you have is you have a process of biopolitics that comes from that conflict. So it's not just that you create climate change and you damage ecosystems and you put uranium in the soil and you use Agent Orange and you feed people crap and you give them your antisepsis and your antibiotics and your antimicrobial resistance. It's that you fundamentally kind of shift their microbiome through that kind of whole kind of process, right? So you can think of it as a conflictome. Each conflict has its own microbiome. And in the modern phase, like you were talking about penicillin, right? So penicillin, is a very good example of biopolitics. At the end of the Second World War, what the Allies decided to do was that they were going to make the production of that secret, and they weren't going to share it with Russia and China. And it became a black market commodity, right? And it's because of that the Russians invested heavily in phage. So phage, if you don't know what phage is it's a virus that affects a bacteria, right? And they're one of the most prolific self-replicating, forms on the planet. But the Russians heavily went into phage. And in fact, the US and Europe had really been looking at phage as a really valid and viable therapy for killing pathogens. And kind of, one of my absolute heroes, a guy called Felix Durrell, who's this kind of total maverick legend of a Canadian microbiologist, was solving pandemics in India and all across the world with phage. But because we perceived phage as being a product of Stalin and Russia, we didn't adopt it. We went all in on antibiotics. And guess what? Now, when our antibiotics are running out, what are we going back to? Right? So we are shaped by biopolitics, and it's completely transformed our ecology. And again, every conflict up until today, the conflicts that are going on right now are having the same impact.
Sorry, I'm stunned by that. That's an incredible story. We'll go for Lucy and then the gent over there. So, Lucy, you can ask your question and pass that along. And yeah, James needs to leave on time, so I'm conscious we need to get you to your next. Yeah.
No worries, I'll try and keep it quite short. You've covered a lot, and you've also emphasised the fact this is a young science, 20 years. So for you, or I guess maybe for the science as a whole, what's the important next step? Is it education? Is it discussing how we apply it? Or is it more trial and error and figure out, we need to learn more before we apply? What do you feel's next?
Okay, so I would say that the first thing that we need to have is what I would call standardization. So instead of like lots of different groups all around the world replicating work or using different techniques or different approaches in the clinical application of microbiome sciences, we need to decide collectively, okay, what does good quality look like? And how do we make sure that we do that across the board? Because we suffered from a lot of bad studies getting overhyped and then them failing, right? So the big example of that was the placental microbiome, right? That was a catastrophe. The second thing that we need to do is focus on what we don't know yet, and there's a big piece of what we don't know. So we don't really know what phage or the human virome is up to at all, and it dwarfs the bacterial microbiome by like a crazy amount. So there's about, I don't know, the average person has about 500 to 1,000 bacterial species in your gut. There's probably about 150,000 species of viruses. No idea what any of them are doing, how they're interacting with anything. No idea.
But we're not worried.
Not worried. No idea what yeasts are doing, really. No idea how they're all interacting with parasites. We need to figure that out. And then I think what we need to do is create an ethical framework for engineering the microbiome, because that's happening now. We are synthesizing new life forms and we're going to start putting them into people, and we have no idea what the implication of that is. And God, like, it drives me nuts. You can't open a newspaper today without reading about bloody GPT-3 or AI and the rest of it. But that's going to have a big impact too. That's just hugely ramping up our understanding of how these super, super complicated networks that historically were only comprehended using supercomputers in California are now being interpreted. And so I feel like we're kind of right on the edge of something really quite big. And then, of course, my big thing, this is really a policy book, right? Like, how do you get this into healthcare policy to do the thing that I was talking about earlier about diet? Actually, if you could just all go home and eat 7 grams more fiber per day, I'd be so happy, because your risk of diabetes will go down, your risk of obesity will go down, your risk of cardiovascular disease, your risk of cancer will go down. It's all mediated through the microbiome, or at least the majority of it is. So I think there's a lot of work to do. It's super exciting. It's a great time to be a microbiome scientist if you are one. And I think it will come into the lexicon of kind of clinical practice in due course.
So that's like 2 slices of brown bread
Yeah.
and some vegetable soup,
Yeah,
basically, right? So you've had your hand up for a while.
Yeah.
Oh,
Yeah.
that's your
it.
alarm. So
Okay.
we could keep this one super
Yeah.
brief.
Yeah.
That'd be great. Sorry.
So Zico, thanks. I was wondering, is it when you look at the microbiome, you're like, wow, this person has the perfect microbiome, and if only everyone got there. Yeah. And if that's the way, sort of thinking about it, but then going on from that, sort of, do you think that we'll go down like a policy lens of like, okay, everyone has a right to a healthy microbiome, this should say, so how we shape the world, or like we're going to create super soldiers who like can take over the world because this makes them like this.
Spectrum of options.
To kill all the people that don't have perfect microbiomes. So look, the question I ask consistently, there's a word I really hate in microbiome science, which is called dysbiosis, and it doesn't appear in this book because it's a bullshit term that doesn't mean anything, right? Because we don't know what a healthy microbiome is. To understand what a healthy microbiome is, you've got to know when it's healthy and what it's doing, and you've got to understand its function over time, right? And we've talked about the microbiome in the context largely of ecology in the last 20 years. What we're going into is a period of function and effect, cause and effect. And I think that, so there's an urgent need to define what a healthy microbiome is. What we have learnt, however, is that individual variation it overcasts absolutely everything. So your microbiome and my microbiome are completely different because you presumably kiss different people, I hope so, and you eat different foods, and you come from a different part of the world, and you right? So actually what we're getting to is, and I think someone asked the question earlier, is precision healthcare. It's personalized healthcare. How do I know that the drug is going to work in you precisely? And if I give it to you, you're not going to have side effects. And how do I leverage the microbiome to understand that? So I'm arguing that you can't have personalized healthcare without the microbiome. It is impossible.
I think, really, I'm sorry, that's all we've got time for, but James, thank you. James, you've had a lot of fun writing this as well. That really comes through. You can tell that you've had a blast in operating theatre number 3. Quite a dark time, but there's a lot of fun in this book, and tons of information. And even if some of it is quite scary to read, you've got your homework. So go home, eat fibre, kiss different people for 10 seconds at a time. And what was the other one? I think that was it, actually. They're the main ones. And maybe swerve the Martine McCutcheon yogurts, because they're not doing you any good. Thank you so much. Thank you, James. You've been amazing. My colleagues are taking orders for James's book. We've got signed copies, which will be shipped out this week. But otherwise, thank you very much for coming, and see you soon.
Thanks for watching that video. There's plenty more over on our channel, so just click here to subscribe.